Hello guys, welcome back. Last time as we discussed, there were some bugs. I went through them, I discovered some bugs and some more bugs I discovered. And along the way, I have thought of changing some architecture. Firstly, let's fix one of the bugs. One of the bugs was memory queue implementation is broken. This I saw why it is broken. It is because of a deadlock, which is simply here. Can go to memory.co where it is. At one place we are using the length function. Yep, here. Here we are using the length function. The length function itself has a r-lock, while inside this enqueue we have a lock. So when we try to get a r-lock while having a lock, it causes a deadlock, making the condition not fulfillable. So this part does not work whatsoever. So what I'll do is I'll just take the in-memory structure, in-memory heap, and take its length, just like we did here. Where is it? What the f equals to job h dot length. Yep, that's correct. That's not the issue here. The length function is here. No. This was not the issue. There was one place I checked where there was, maybe in job builder. I don't remember. I checked day before yesterday. Exactly, it was at one place we were setting the metrics for the in-memory queue. Here's our in-memory queue. Here's our in-memory queue. And we were using other function while still having log for one function. So store.rlog, we are not using anything here. It's valid transition save. There's a lock. This isn't there. Update status does not. I need to check for the metrics wherever we are setting the metrics. Readme should not be there. Git log should not exist. Change log should not have. Okay, we don't want here. In server.o we don't need to check here. In DLQ it only covers the Redis key, so it is not here. Matrix don't have. Memory dot. I have to check different metrics here. So I'm setting the matrix here, and I'm setting the matrix here. Just memq.job h.length. So I'm using the heap.length function. The heap.length function, what it does is it will return length of the job h, which is as simple as it can be. But alright. Any other place? This shouldn't be the issue. Set queue depth, and queue depth. Job h.length. And queue dot, we are using the job dot length. This shouldn't be the issue. Where was the deadlock I discovered then? In the Redis implementation it shouldn't be there. Here it is not there. Maybe I fixed it. I have to check it. Well, let's go with the project. Go build, and let's run the in-memory value and give it a call. Normal job with a delay of 1 second, 5 seconds, I guess. 2 seconds, okay. Should work in 2 seconds. 1, 2. It isn't working. Still the dead. It means the deadlock is here, but I can't find it again. I have to go through the code again. Shit. I should have written it somewhere. No worries. Let's fix it. Memory.go. The memory.go have empty while having a lock. I have a lock here. I push into the push does not fit. They don't have a lock. So NQ should work fine. Maybe somewhere other than this, when we are calling the API, when we call the API, we call the NQ function. Internally it should go here. Then we get the lock and NQ.lock, job.run after, .run 0, and do we call anything else? No. And DT then for q.job.h, job.h.length. No. Okay. Here it is. Job.h. That was all the issue. This was causing a deadlock and my process can't be shut down because of that deadlock, because our system can't be gracefully shut down. Let me build and then try it. GoTaskQ. It built its everything there, and let's try again. And this time it should work fine. Yep, fixed it. It was the issue of deadlock. I saw it last time but forgot where was the issue. Sorry for that. Now coming to the multi-queue part. Let me just close the server. Okay, so after closing server, let me just clear this all. Firstly, I should use Redis. I could have used command line, but I write my 60Q method to use. 60Q method to use. 60Q method. Deadlock code. Okay, I'll seek the change. Okay. Now coming to the other parts. What were the other parts? Let me just go to there. Issues.txt. Okay. So worker in matrix is always rendered. So I have two options here. I can spawn workers while they are processing the job in the matrix. I mean, in the matrix I can have worker count increase while processing and decrease after that, or I can keep it as is, which will tell us how many workers are present up there. So I'm thinking this approach is fine for now, so I should remove this from the list. Okay, and this is fixed. Now coming to the processing of jobs not happening outside default queue. In the default queue, now let me tell you what is the issue. I went through the code. The issue was that we were registering the worker pool with the queue itself. Let me just go to the worker pool and give you the glimpse of it. So the worker pool and itself takes a queue and registers to it. So now I have two solutions proposed. I can tell you like I had two solution for worker pool taking few parameter. I can first what I can do is I can keep the implementation as is and spawn worker per queue. But that would be a bad choice because uh, currently the default value of workers, as I say, is 100. So if 100 workers are at one queue, 100 workers at one queue, that will spawn. Uh, if let's say we have 20 queues, 20 different queues, that will spawn around 2000 workers. 2000 workers will be a lot of stress on our core runtime, and the program might crash or behave slow. So this implementation is easy to implement, but hard to scale. We can't scale this. Okay, so for this, there is one more implementation in my mind. That is, I can create a scheduler on the worker pool. Now, the idea behind the scheduler came from reading open source code from a queue implementation known as async queue. You can go to their this is the GitHub name, async queue. So what they do is they have a worker pool that has all the workers in it. Let's say 100 workers in it, but they schedule the workers to different queues. They use priority based scheduling, so each queue has a priority attached to it. But what I am thinking is, instead of doing a priority based scheduling, which will change the underlying architecture of everything like queue and all that, I can simply keep this architecture as is and just change the scheduler. I'll make the scheduler to be a round robin scheduler. In OS classes in computer science, you must have read about round robin. It gives each queue. It will give each queue approximately, I can say, approximately equal priority, but also there are some trade-offs. Also there are some advantages. None of the scheduling is as good as it can be. If I did instead of round robin, if I did first based scheduling, like the first queue that I can say like the first queue that responds. So the faster queue will be always getting the worker pool, and the slower queues will have to wait. So a round robin is what I derived. So for round robin scheduling, what I'll do is, let me draw a diagram. So what I'll do is, I'll have a inside the worker pool. Let's say this is our worker pool. Let me draw. Oh look. Let me just read it. Let's say this is a worker pool. It will have multiple fields. The old fields like the, let me just write it, like store and registry will remain as is. Store this thing, registry and all will remain as is, except for the queue primitive we passed. Queue argument we passed, except queue will not be passed here. Okay, so it will not have a queue. It will not have a queue except queue parameter. It will not have a. It will not accept a queue to initiate the worker pool. So everything will work. Store, registry, and all that will work. Instead, what it will do is it will have a queues array, or what we call in Go a slice, a queue slice, which will be like storing all the queues which are currently active, which whenever a new queue gets registered, it will be automatically added to the queues slice. And then we'll have a, let me write it, queues name, something like that. It will be a slice of empty struct. Slice of it will be like let's say instead of this, it will be a map with key string and value is empty struct. I am using empty struct as I don't concern with the value, and empty struct will take 0 memory, so memory overhead will be nil. So this will be only the important part. I'll check for the string name. Then for round robin, I need some other things that are let me write it. A cursor. A cursor will be like a pointer to the last queue executed, last queue processed. Okay, so it will be like a pointer which will tell us which queue to process. Instead of pointing to the last queue processed, pointer which will tell which queue to process, which will tell which queue to process. And I can remove this. I think this is not helping me. Okay. Now I have this. Okay. Now I have a cursor, and I will have a, for round robin, I'll have a something like a boolean. I'll have to have a boolean which will tell me if the queue processing has been started. So I will name the boolean as started. Bool tells if queue processing has started, so that no other worker can take the queue again until its started has been false. Now, how will the worker know that the queue is active? For that, I'll have a channel which will be wake channel. It will take an empty struct. It will be like empty struct. Okay. So whenever a notification comes here, the worker pool will wake up. How the worker pool will wake up? That's up to the implementation. I'll write once I just give a glimpse of what we are going to do. And the worker pool will have unsubscribe array, unsubscribe function slice. So it will create, it will have functions to unsubscribe to the notification of a queue. As we have designed earlier, the pub sub has a unsubscribe method. So if if the worker pool wants to unsubscribe to the queue for graceful shutdown, this is important. So this is what we are going to do. And one thing more, we need a mutex lock. So why the mutex is needed? So it is needed that at one time only one worker can access this place. Okay, so I think I am good to go with the implementation. This is how our worker tool will look. If there is some change, I'll write it while writing the code. So this is the first thing we need to do. After that, the things we need to do are we will have a dynamic worker pool queue. This is what we have done. Next we need to do is yep, we have to implement one more thing, that is TTL for jobs. So last time, as in the stream, we saw there were thousands of jobs. That was during the testing when I created 1,000 jobs. So there were 18K jobs which were never expired. So what I'll do is I'll have a TTL for each job. That's easy for Redis. But for memory based jobs, we have to implement expiry mechanism. Expiry mechanism. Okay, so this is what we need. Then anything more? We need to change small things along the way. But firstly, let's start with the worker pool implementation. The testing also, I'll write some tests along the way so that I can test the behavior. And as I promised, from Sunday onwards, I'll write all the tests for these. But for small issues, I'll write the tests along the way. Okay, so let's start with the worker pool. What I need is, I need to remove the queue struct from here. This is going to cause a lot of problems for now. So I'll not compile the binary until the queue has been completely stabilized. So the things I need more other than these are store, registry, retry. We don't need access to DLQ and matrix, that was planned earlier. Retry, the num workers. Then we need a wait group, that's all we have. Context and a cancel function, that's all. Now we need a mutex. Mutex, let's name it mu. As I discussed, it will be for atomic operations. Okay, now along the way I need queues. Queues. Let's name it queues. It will be q.q. It will be a slice for q.q. Alright. Next thing I need is queue name. QUEV names. It will be a map of string and empty struct, as I told you. So we will just have empty struct here. Next we need a cursor to interact with what is the current position of the we are in the queue slice. It will tell us what is the current position we are in the queue slice, and then a started, which is a bool. Okay, what were the other things we needed? A wake channel, which will be a channel of Okay, and unsubscribe slice. Unsubscribe. Unsub will be good, but let's write it. Unsubscribe. That will be a slice of function. Slice of functions. Yep. That's all we need. Let me write some comments while we are working. New text is as normal as we can be. So queues plus cursor implements round robin polling or scheduling. We will have a polling because we are not scheduling, we are polling for queues across registered queues. Okay, next thing we need to do is we need a any more comments we need. Queue names is just for the significance of what the queue is currently named. And a channel. Yep, I should write a comment here. Make yes makes worker to stop waiting. So the workers will be in waiting phase. I'll have phases when the worker will be in waiting phase, and whenever new work or notification comes, they will awake and fetch the queue and process the queue. Vacation. Okay. Lastly, unsubscribe. This is handle cancellations for functions to cancel person per queue per queue. So this is all we need. Inside the new worker pool, there are changes. Firstly, we don't need the queue. This will break the system because main depends on this. So for the sake of it, I'll change main after this. But for now, we don't need the queue. We are going to keep the code as is. Context is okay. Remove the queue. Right? We'll remove the queue. What we will initiate is a queues which will be make. Okay, so it will make a queue slice with 0 value, and then I need queue names. Sorry, zero size, and I'll do is I'll also make a map of ducks here, and lastly wake channel. In the wake channel, I'm thinking of using a buffered channel. Buffered channel will be helpful. If I have a buffered channel, if 100 notification comes, that will cause system delay. So if I have a buffered channel, 100 notification will converge into one wake up notification. So that's why I'm using wake channel, so that even if simultaneously 100 requests come, it will only take one request at max. Make channel struct, and it will be buffered. Nice. So okay, now since we don't know which are the queues in this, so we have to add a function to add queues into the what do we call it, our worker pool. So we have to have a function to add queues into our worker pool. I'll expose the function just like we expose the start and stop function. It will take tool start tool and it will be add queues. So what it will take as parameter is a queue which will be a type of queue. That's all we need. First thing we check is if queue is nil, then we will return out of this. We will not pass any error for add queue. Should I pass any errors or should I not? Here I should no, I'll return just. I'll not even print. I should print even. Let's see. If what is the printing strategy I'm using in this package, log.printf. I'll just copy this. Log.printf. I'll just name it q to add is nil. Okay. Next we will do is we will lock the queue. We will lock the worker queue. Okay. We will lock the mutex. We will check if the queue exists in our queue names. So queue names will tell us what are the queues which already exist with us with the worker pool. If a user tries to add a queue 2 times in a row, we'll just return by saying queue already exists, something like that. So what I'll do is if not exists in our pool.queue names in our map, if the queue with the current name exists, what I'll do is I'll return. Also I need to unlock the tool.mu.unlock. You might be wondering why did I defer the unlock, because this is a small thing I need to do. After this I have to add some more things, so I'm not going to defer to this. Okay, so one more thing, if exists, I'll do is log dot printf and log dot print. Okay, I should also use log dot print here. I'll print queue already exists in worker pool. Okay. The next thing we need to do is we need to, if a queue does not exist, so we need to append that into our pool.queues, and also we'll need to add the name of the queue, so that again if someone tries to add into our queue, we will have it as empty struct so that the memory overhead is nil. And here we will have tool.mu.unlock. That's why I never used defer. Now you will see why I never use defer. Whenever a new queue is added, we will notify the workers that a new queue has been added. So what I'll do is I'll copy this from here. Okay, and I'll add this to here. One thing I need before this is a way to wake up the workers. So let me just write a small function that will wake up the workers. So it will be like pool fun on a pool. It should be wake worker, something like that. It will be a function that will wake up the workers. So what it does is it will block. It is simple block statement which will case case. It will pool dot wake channel. If we get what the why I didn't case. Okay, pool dot. I am not getting the XCH. If we get any notifications in it, then it will unlock, and the default case will make it lock. Okay. Yep, it's working, but it was not showing. Okay, so this is a simple blocker. This is also what keeps the workers waiting. So this is not this is not what we keep the worker waiting, but this is what will wake up the worker if anything happens into the wake channel. Okay, so what I'll do is here everything looks good to me, and it is not what I need to write a function. I need to write a function. Well, let's first write something like that. So what we'll do is here in the notifier, what I'll do is if notifier, okay, I'll take from here. It will take a queue. So queue dot typecast into notifications. We need like notifications dot subscribe notifications. No, we don't need to subscribe notification, but we are just typecasting it here. So we have a notifier from here. So notifier dot subscribe notifications will work. This will work fine if error not equal. This error does not need to change, but here things need to change. First thing we do is we'll lock the mutex. Okay, so I'll lock the mutex, and I'll add the unsubscribe. Yep. I'll append to the unsubscribe a function which we get from here, which is our cancel function, as we got from here. So I'll add that to the unsubscribe array. So now we have a queue name, and the unsubscribe function for that queue. Okay, so what I'll do is I need to forward the notification to the worker pool that that a new queue has been added, something like that. So what I need to do, a new queue has been added or removed, then like I need to tell the worker pool whenever a new queue gets added. So for that, firstly I should unlock the mutex. Okay, so I need a function to forward notifications. The notification I got from here, this notification that we have subscribed, I need to forward it to our what we call it, the worker pool. So what I'll do is I'll write a small function, but before that, since it's a asynchronous task. I'll add a weight group to one, add a weight group of one, and the forward notification will uh, complete the weight group. So let me just do it. I'm not good at I can tutoring the stuff, but I can just write the code. I hope you understand. Star rule. So what it will do is it will forward notifications. Once it will take a channel, a read-only channel. A read-only channel. What it will do is it will defer pool dot weight group dot done. So it will subtract from the weight group. This happens. For we'll use for select here. For select, there will be two cases. The case one will be when what I'm writing is pool dot context gets done. Then what we'll do is we'll return from this. Okay, if the channel we got is context dot done, we'll return. If it is a normal channel, which we will check by okay, is a read-only channel. What I'll do is if okay, I'll return and sorry, if not okay, I'll return, and if it is okay, I'll call the wake workers. Pool dot wake workers. So it will wake up the workers by forwarding the notification. So that's all we need to do here, and call this method here, pool dot forward notifications, and the channel stuff will be here, and I think this will work fine. If notifier is not okay, if sometimes the notification it pops up, sometimes fails, we still need to tell the worker pool to wake up, because the new queue has been added. So I'll just do wake workers here too. Okay, so this function was for forwarding notifications we got from the PubSub, and this function happens if PubSub fails. Still we will call the wake workers. Okay, for now everything looks good to me. Next thing we need to do is change the start function as well. The start function, what it does currently is simple task, which is spawning n number of goroutines. So what we'll do is we'll use the started here. Now you might be wondering, how can I think out of fly, but I have prepared for the stream before that. So let me just pool.nu.l. Let's lock this. What I'll check is if pool has started. Pool dot started. So the started boolean is telling us, just like it, tells us if can you hello is my stream visible because OBS just disconnected for a second. Let me check on YouTube. What's the issue? Let me check if my encoder. Oh, my encoder is off. Hello, hello. Am I live? Yep, now I look live. Hello, hello, hello. I have to check if I am live. How can I check I am live? Yeah, I'm live. There was some OBS issue for a second. Sorry. So what I was saying is, the started will tell us if the pool of worker has been initiated. The old definition was wrong. Sorry, but the started will tell us if the pool of workers has initiated. So where was I? I wasn't writing. Yeah. If pool has been started, what I'll do is pool.mu dot unlock and return. So I'll not go through the start function. If not started, what I'll do is pool.started equals to true and pool.mutex.unlock. I'll unlock the mutex. Then I'll spawn the goroutines as they were spawning, and at the starting of the pool, I'll wake the workers once. Pool wake workers. Alright. For stopping, let me check. I need to do is pool.cancel. This was already being done. One thing more I need to do is, in between waiting for the wait group to finish, I also need to unsubscribe to the PubSub. So what I'll do is, I'll have a mutex pool.mutex.lock or unsubscribe range of pool.unsubscribe. I'll call each unsubscribe function. And then I'll unlock the mutex. Pool.mutex.unlock. That's all I need for this one. Now coming to stop is done. Now coming to make workers and changes in other things. One thing more I need is, how will I EQ ready jobs? Okay, so let's start with the run worker. As we write the run worker, you will understand what I am saying. So the run worker currently does this. It defers pool WG done, that will be done. It increases the active workers. Okay, this is okay. Defers it's not whenever workers stop, it will decrease active workers, and we don't need it here now. Reference is right. Okay. So we go to the for select loop. For select, if context is done, the default will be since we don't have the EQ access, pool queue access, we need to write a small helper function to dequeue the ready jobs. Okay, so what we will do is, let me write a small helper function. Func dequeue ready jobs. Okay, so what it will take is it will not take any argument, but it will return us a queue and job and boolean. Yep, a boolean which will tell us if the queue is ready or not, because we have multiple queues. So let me just write the implementation. You will understand once I write it. For each queue, now how will we know? How will we know that the queue we are using are how can we know that at one point there can be issues, like let's say I am a user and while the DQ ready jobs is working, I add one more queue. What will happen then? That will cause a race condition. So to tackle the race condition, I need to save the state of the queues once while dequeuing the jobs, and after the DQ has been done, then only the queue will be added. I mean, the queue will be added, but the state will only give us the queues which we already have. For if I do something like, let's say, for range pool.queues, this will cause a race condition. What if user adds 100 queues while we are still querying for queues? That can cause unrecognizable errors. So what I'll do is, I'll have a small snapshot of the queues before processing. So let's take a queue snapshot. So for that, let's create a function. So it will be queue start queue. It will be queue snapshot. So it will take a snapshot of the queues currently present. It will give us queues. Queues.queue. It will give us a slice of queue.queue. What we will do is pool.text.lock. We'll lock the queues as is, so that no other queues can be added at the same time, saving us from the race condition. I'll defer the unlock here. Pool.mu.unlock. Okay. I'll count the current number of queues we have, and pool.queue. We have this much queues. If count equals 0, I'll return nil. This means there are no queues. Next thing we need to do is, we'll create a start pointer, which will be pool dot cursor, the current position of cursor modulus count. So this is a normal trick that will keep the range of the cursor inside the count. Okay, now also we need to update the cursor. Pool dot cursor equals to pool dot cursor plus 1 modulus count, again to keep it in the range of the counts. Okay, so this is all we need. We have a start pointer. Now what we will do is we will make a copy of we will make a queues what we say queues, make and slice of queue zero and size count. Okay, so we will have a slice of queue because we need to return a slice of queues. What we will do is for offset in range of our count. For offset in range of our count, we'll do is queues.append. We'll add queues to it from the worker pool.queues with the cursor the start plus offset. Start plus offset modulus count. So let me simplify it. What I'm going to do is I created a start which is at the current cursor position. Okay, so this is where all the round robin happens. What we do is every time whenever a DQ ready job is called, we start from the next queue. I mean, if there are 10 queues, firstly we'll start from the first queue. So start will be first, and it will be like this, and it will send the details from the first to the 10th position. But if the start is 2, it will send the details from 2 to 10 and then again 1 at the last position. Something like that. If you can understand, it will create a cycle in which every queue will have a chance to get to the polling area. It means every queue will have a chance to DQ the ready job. So what I'll do is here after appending, I'll return the queues. The queues slice starts from the cursor position up to the end of the queue, and added queues like the queue which have already been processed will be at the end of the queue. So what I'll do is pool dot queue snapshot. So now we will arrange over the queue snapshot. Okay. Now we will check if any of the job is ready. So what we will do is dq'd job, dq'd job, error, which will be like queue dot dq our dot context it needs, and anything else? No, I don't think it needs anything else. If we get any error, if we get any error, we will just continue our processing. If error is nil, it means we got a DQ'd job. What we will do is we will return the DQ'd job, return queue, which is our range of queue snapshot, DQ'd job, and a boolean which will set to true. Okay, so it means there is a job ready. Okay, next thing we need is if none of the job is ready, So what I'll return? Return is nil, nil, and false. Getting to this, I don't think any queue can get to this point because DQ ready jobs will be called only when there is no, there are chances to get. Okay. This is okay, alright. So what we'll do is, I was writing the run worker. The run worker, instead of q.dq, we will do pool.dq ready jobs. Okay, so we will have a queue, a dequeued job, and an OK, a boolean which will state if there is a dequeued job. So what I'll do is, I'll remove this part of code. This is not what we need. This is already handled above. If not okay, it means none of the job is ready. So we'll make the worker pool wait. So now to make the worker pool wait, we will have to write a function again. A small function to make the worker pool wait for work. Okay, let's write the function. Function pool char pool. I will also clean up this code. This code is somewhat horrible for me right now. I'll just make this distributor like the helper functions will be in one place, the main functions will be in another place, and all that. Okay, so wait for work. What we will do is, we'll wait for work. In the wait for work, I'll set a timer of let's say 100 milliseconds. That let the jobs be, let the workers wake up every 100 milliseconds. Time dot now no, time dot new timer of 100 into time dot millisecond. Okay, and defer, will defer time dot stop. So even if sorry, timer dot stop, what I was writing is wrong. Timer dot stop. Even if the worker gets waked up because of any other notification, it will stop the timer. So we will block here. This is a usual case. What I'll do is case. I'll have 3 cases here. First case will be our pool.context.done. It means context has been completed. It means there is a chain of commands from the upper channel, wake channel, and to block this I need this, and a case that will be for the timer. Timer dot c, and this will also be blocking. Whichever finishes first will wake up the workers. So the workers will block at this part of the code until any of these 3 conditions finishes. So the next thing I need to do is, I'll have to wake up the workers. So if not okay, what I'll do is pool dot wake for I'll wait for work. If not okay, it means the dequeued jobs are not ready, so I'll wait for work. Next thing I need to do is, I have to check for the dequeued job and start the processing of it. So what I'll do is, think about it. One more thing I need to do is continue the process so that the this loop does not get broken after this, or we don't go past this point. I need to continue the loop for the next iteration. If we get error, if we get error in the job, process job, pool dot process job, we will process the job to the queue and dequeued job. Process job also need to be changed. So for now, let me just give you the context. It will take the queue and the dequeued job. So if there's no error not equals to nil. So what I'll do is log dot printf and printf. It means if there is error, we will printf worker with the ID for the queue, which will be the name of the queue. Failed to process job, which will be the job ID, and with error, which will be present v, let's say, and let's pass this. The first thing we need to pass is worker ID, which will be ID. The second thing we need to pass is our queue name, which will be queue dot name, and the third thing we need to pass is the dequeued job ID, and lastly we need to pass the error along with it. That's all we need to pass. Because there's an issue, too many arguments. Yep, I need to change this now. Now for changing this, what I'll take is, it will take a queue, which will be a type of queue.queue, and a job, let's call it j, which will be pointed to job.job, and that's all we need from here. Queue name equals to unknown. If pool.queue, instead of pool.queue everywhere, we need to add in the run worker, we need to in the process worker, in the pool, instead of pool.queue, I need to add queue. If queue is not equals to nil, then we will set the queue name is equal to this. If job types is equal to known, this will work fine. Start the timer. Status is equal to failed. We will defer the function. Metrics observe duration and all that is fine for now. This is fine. Mark job as running. Update status. It updates the status, and this will work fine. Refer function, this is recovery function. Our recovery function does not need any change. Get handler does not need any change. Execute the handler does not need any change, and mark the job as done does not need any change. So I think everything will work fine. For now the worker pool is working fine, looking fine to me. There's one issue here. Yep, here. Undefined ID. So I didn't pass along the ID. What is this? Worker %ID, queue notification to thread. Oh, I didn't pass. We didn't need to pass this. Worker. The error should be like add queue we will pass the queue name. Tell which queue has been queue dot name and an error. Okay. So queue notification failed. Subscribe failed. Queue notification subscribe failed. Okay. Alright. This looks fine to me. One more thing. Any errors we need to look for? I don't think so. I think the worker pool has been completed. So let me just format the worker pool. What I'll do now is I'll write some tests for the worker pool, and also one more thing I'm thinking is, after the job processing has been done, I'll call the delete function here so that the job gets deleted. But as I discussed before, delete job after completion. I'll change the delete job function's signature. It will make it a soft delete and expire the job after set time period. We'll check if there is a delete error, which will be tool.store.delete. It will take the context, which will be tool.context, and an ID. The ID will be our j.id. That's all we need. And if there is an error, if del error not equals to nil, if del error not equals to nil, instead I can do is, what I am doing is del error not equals to nil. What I'll do is log.printf. Now I will log.printf, and what I'll printf is failed to delete job %s from store %v, which will be our error, and %s will be j.id, and the error will be del error. That's all I think we need to do in the worker pool. I am thinking this is looking good to me. I'll check if something needs to be changed, and I'll tell you once. What I'll do next is write some test for this worker pool. Also, next thing I'll do is write the TTL functions. Then also one more thing to do is have this not pass the main key. So let me just format it down, and this is looking good to me. For now, this looks good to me. I'll not pass along the main key for now. It will create a new worker pool which will display this. Add queue, we did add the queue here. So I'll not push the main function for now. I'll only push the pool.go for now. Let me push pool.go, and I'll complete today's stream with this one. Let's say tomorrow I'll write the test for this, and also I'll write the TTL function, that is a small function. Also anything more, I don't think. Then we'll check for bugs. If if there are no bugs, I'll do is I'll change the structure from a binary to a library. Okay,